Welcome back. Today we're talking about section 1.5 and triangles. On the introductory slide here, you can see some triangles being used in architecture. On the left, we have some skyscrapers with some very interesting, looks like maybe isosceles triangles. Top right, we obviously have the famous Egyptian pyramids. And in the bottom right corner, a very unique house, obviously made of triangles. So we start out by defining right triangles. On the left, some examples of a right triangle. On the right, not right triangles. By looking and comparing these, we can see that the definition of a right triangle is a triangle with one right angle. Acute triangles. On the left, we have acute triangles, and looking carefully, you can see that the measure of each angle is less than 90 degrees. On the right, we have not acute triangles, and you can see that in each of those triangles, we have at least one angle, or we have one angle, that is at least 90 degrees. So the definition of acute triangle is a triangle with three acute angles. Obtuse triangles. On the left, we have two examples of obtuse triangles. You can see that in each example, there is exactly one obtuse angle. And on the right, we have examples of triangles that are not obtuse. Perhaps not a triangle at all, or an acute triangle, and in this case, a right triangle. So the definition of obtuse triangle is a triangle with one obtuse angle. Scalene triangles. On the left, we have three examples of scalene triangles, and on the right, we have some examples of triangles that are not scalene. Looking closely, we can see that a scalene triangle is a triangle with no congruent sides. Equilateral triangles. An equilateral triangle is a triangle with three congruent sides. You can see to the left, we have examples of equilateral triangles. The tick marks here indicating that those three sides are congruent. And in the second triangle, obviously, if side lengths are equal, then sides are congruent. An isosceles triangle. On the left, we have four examples of isosceles triangles. If you look closely, here we have two congruent sides. Here we have two congruent sides. Here we have two congruent sides. And interestingly, here we have at least two congruent sides. On the right, we have three examples of triangles that are not isosceles triangles. So by definition, isosceles triangle is a triangle with at least two congruent sides. Pay close attention to the phrase at least, because as we saw up here, this is actually an equilateral triangle, but it also classifies as an isosceles triangle. Parts of an isosceles triangle. The vertex angle is the angle between two sides of equal length. The base, the side opposite the vertex angle. And base angles, the two angles opposite the two sides of equal length. So if we were to draw an isosceles triangle, this is sort of your classic isosceles triangle, where the vertex would be the angle at the top, the base would be the side at the bottom. Let's label this vertex angle. These are our two congruent sides. So this would become our base, and these would become our base angles. Now, what if we had an isosceles triangle that was actually equilateral? So let's go back and redraw. That looks pretty good. I'm going to use some blue. So this is actually an equilateral triangle, which we know is also isosceles. Well, in this case, we actually could choose which angle is the vertex angle, because any of the three angles qualify. Well, then the base would be opposite that angle, and the base angles would be the two angles opposite the two sides that made up the vertex angle. So for example, if I chose to call this the vertex angle, then this would be the base, and these would be the base angles. Of course, I could switch that around. I might choose this to be the vertex angle, in which case this would be the base, and these would be the base angles.